This is the Framework desktop PC running SteamOS. It has the world's most powerful APU, the AMD Ryzen Ai MAX Plus 395. But this isn't a review of the Framework desktop. We're showing how we moved from 4.5 liters of plastic and steel to 3 liters with the Skyreach 4 Tiny. Welcome to NFC. We're showcasing this custom build in the Skyreach 4 Tiny with the Framework desktop Ai MAX 395 mainboard. The price is steep, but you're getting a 16-core 32-thread CPU, embedded graphics that rivals the RTX 4060, and 64 gigabytes of DDR5 memory at 8,000 megatransfers per second. Compared to a similar build with a dedicated GPU, the price looks reasonable, especially considering other benefits like portability, power, efficiency, and exceptional AI performance. However, the SoC and RAM are soldered to the board, which means you won't be able to upgrade those components. Its gaming performance is impressive. Take a look at this direct comparison of Final Fantasy XVI running on the PS5 and on the Ai MAX 395. I'm excited by the recent advancements in APU performance, and I hope the trend continues. We designed the S4T for APU builds, and we finally have one that is worth a serious consideration for your next ultra-small form factor gaming PC. There are a few issues that need to be addressed before we can fit the Framework desktop motherboard into the S4T. The most obvious is Framework's stock cooling solution. It's just too tall. I'm disappointed with Framework's choice to use a proprietary cooling design, especially since this motherboard comes in a mini ITX form factor. You can't use an aftermarket CPU cooler because the mounting holes on the motherboard don't meet standard AMD or Intel specifications. In addition, the APU does not have an integrated heat spreader. The heatsink mounts directly to the APU die. Lastly, the rear I/O ports are recessed deeper than a standard mini ITX motherboard by about 2 millimeters. This means that if you put this motherboard in any standard ITX case, then the I/O shield won't be secure inside the frame. I designed a custom aluminum heatsink plate very similar to the one I made for the Tiny PS5. It provides cooling for the RAM, VRMs, and MOSFETs, and incorporates mounting points for the Alpenphone Blackridge CPU cooler. In my experience, the Blackridge is the best performing sub 50mm CPU cooler, and it's the tallest cooler that will fit any S4T with the fan mounted on the bottom. It can easily handle the 120 watt TDP of the Ai MAX 395. I machined the heatsink plate on my CNC out of 6mm thick aluminum stock, sandblasted the surface, and then gave it a Cerakote finish. The RAM and VRMs make contact with the heatsink plate via thermal paste, and the APU die makes direct contact with the Blackridge using Thermal Grizzly's Phase Sheet PTM. Now I would prefer to use liquid metal, but I want to compare the two cooling solutions, and the stock Framework desktop also uses PTM. The Blackridge mounts to the aluminum heatsink, and then the assembly mounts to the motherboard using 6mm tall nylon standoffs to ensure the proper distance from the components is always maintained. To power the system, I'm using the HDPlex 250 watt gallium nitride power supply. It will mount internally at the front of the S4T using the included bracket that was designed for this purpose. The S4T has a lot of ventilation, but I want to control the cold air intake and the hot air exhaust for the best thermals. I designed a two-part shroud for the Blackridge consisting of a base and cover panel. A single slim 120mm by 15mm Noctua fan mounts to the base and slides over the aluminum fins on the Blackridge. The cover panel slides over the base with a friction fit and is secured with 4 screws using anchor points on the S4T side braces. I 3D printed these parts using ABS glass fiber filament from Bamboo Lab, added threaded brass inserts where needed, and painted the cover panel for a consistent and deeper black color. Since the case will lie horizontally on the desktop, the cover panel ensures that the hot exhaust is vented out of the sky slots on the side braces and via the rear I/O fan. Only cool air will be pulled into the Blackridge from above. Since I'm blocking off a very large area of ventilation on one side of the S4T, I want to make sure the power supply gets extra cooling. I 3D printed a cover for the HDPlex that this 40 by 20mm Noctua fan mounts to. In my experience, it is better to pull air through the HDPlex power supply than it is to try and push air into its small crevices when using small fans. The cover seals the power supply so that only cool air is pulled through this manifold that sits next to the APU cooler intake. I usually make S4T SkyIOs out of single flat pieces of aluminum or carbon fiber, but that won't work due to the deep offset of the framework motherboard I/O. The design of the SkyIO would either need to be two parts, like the one I used on Project Erebus, or a single 3D printed part. In the past, I avoided using a 3D printed SkyIO because of the warping that happens over time. The SkyIO on the S4T mounts using 4 screws, one on each corner, so the large areas between end up pulling away from the chassis frame. I came up with a remedy that doesn't involve double-sided tape. This 3D printed SkyIO has a lip that will latch on the chassis frame from the inside. The gap at the bottom provides clearance through the chassis opening, and then it slides upwards to latch internally. It also has 2 additional pass-through holes for screws to hold the bottom edge in place. The Framework desktop motherboard has limited options for USB on the rear I/O. The stock Framework desktop case has 2 additional USB-C ports on the front bottom, but you have to purchase additional adapter mounts to use them. I use these panel mount USB-C cable extensions to provide 2 additional USB-C connections on the rear SkyIO. There's a lot going on here, but there is still enough room for a custom GX16 power cable connection, a power switch, and Wi-Fi antenna connectors. All that's left to complete this build is the final assembly. But I didn't stop there. Fat Carbon's dark matter is absolutely stunning. It appears to move and breathe with your changing perspective, so I made a solid bezel with embedded magnets for toolless removal. I also made some Fat Carbon inserts for the side braces. I could have made some new side braces from scratch, but that wasn't as fun as modifying the originals. I love the original silver color of the S4T cover panels, but shimmer aluminum Cerakote adds a warmer tone. I imagined the system floating slightly above every surface it rests upon, so I made a low-profile horizontal stand, one that would remain unseen unless you peered under the case. Then I thought, what if I embedded LEDs inside and made it look like it was floating on a pillow of light? Now, I know what you're thinking. That's a lot of time and money to throw on top of an already expensive system. And you're absolutely right. But this is art, and I have no regrets. However, I know that not everyone wants to go as far as I did. So here are the numbers for a price comparison between the Framework desktop PC and a simple version of this S4T build. Again, the price difference isn't as drastic as you'd expect. Assuming you have a 3D printer and you can find a source to make the heatsink plate at a fair price. The real upset is Framework's decision to use a proprietary cooler. Had they made one like the recently announced BD395 Ai MAX motherboard from Minisform, then this build would be easier and cheaper. So if you want to copy this build, then I would wait for that motherboard or others like it. Let's talk about the performance of this custom build compared to the Framework desktop. The Framework desktop has a clear advantage since it can use a full-sized 120mm by 25mm fan. The result is a quieter noise profile and higher airflow, but the case itself is what holds it back. There are only 2 areas for exhaust, and the intake fan isn't completely sealed off around the edges to prevent recirculation of hot air. Both systems are running SteamOS. They share the same overclock of plus 200 MHz on the CPU and iGPU, and the same max TDP of 120 watts. I set the fan curves of both systems to match one another and placed them both in the same horizontal orientation on my entertainment console. All the games shown are running at 4K resolution on the Sony A95 OLED with matched graphics settings. The custom S4T cooling outperforms the Framework desktop, and I'm very happy with these results, considering it's more than 30% smaller. This build wouldn't have been possible without our amazing Patreon supporters. A huge thanks to Matt, who sent me the Framework desktop motherboard. The files for this build are available to download on the NFC Patreon. If you're not a supporter and you would like to support us, then you could sign up via the link below. Thanks for watching.